All right, let's begin. I am recording this session. Just double checking. Yeah. So I am talking, so hoping the audio is fine. If not, if it's not clear or if there's any issues, please give me a heads up. So I'm going to start by sharing my screen, and today we're gonna go over Learning Unit 4. Um, this is quite a useful learning unit. It's used a lot in different industries. It's quite powerful. So let me just get to my screen whiteboard so I can kind of give you some context. So the this learning unit is regression and correlation, right? So these tools are used for forecasting, or in other words, predicting the future, making estimates. It may not just be future as in time, but also just making a prediction if something, a new sample comes through the door. Well, I'll kind of explain that now. So for prediction, let's say we want to estimate what the future value is going to be. So I'm going to draw here two axes. This is your x-axis, and let's say it is here we have time. Okay, so I'm just going to put time, and it can be in years. So say year 1, year 2, etc. All right. So say we have some data, and we have time going on this axis, and in the y-axis we have sales. All right, so we have sales, and this can be in any units. It can be in millions or thousands, etc. So what we find is we find that the sales kind of behave like this. So we captured some data. So in year 1 we found the sales to be this, year 2 sales to be that, year 3 the sales to be this value, 4 year to be that. You can maybe observe some sort of pattern here. You can see that as time increases, sales is increasing. So what we can do is look, it's what we say is this data is not smooth. It doesn't follow a straight line like this, like what I'm doing on the right. It's not perfectly in line with a straight line. But if we use a straight line to kind of fit the data in a way, then it's not a bad guess. Okay, if we're willing to be off by a certain amount, we can still use a straight line to do a forecast. And when I say forecast, I mean prediction. So say in year 10, we want to guess what the sales is going to be. We can use this line to estimate what the sales is going to be. So that's quite useful, and you can see in very different industries, this is used for the same reason. It's a powerful statistical tool used to estimate. So in order to use a line to estimate, you have to know some sort of maths in terms of what the equation of a straight line is. Some of you, if you did maths in high school, and if it's also you've completely forgot about it, um, just know that the equation for a straight line is y equals, and there's different symbols here. I'm going to use the symbol m because in high school we use mx plus c, where c is where the line cuts this y-axis here, where it cuts the y-axis. It's the y-intercept, and m is the slope. When I say slope, I mean how steep this line is. So for instance, this line, say this line that's true here, this line, say this slope is 1. If we have a steeper slope, so it's, and I say it's steeper, it's like, I'm not try and explain this without using mathematical terms, but the gradient, or in other words, the steepness of the slope, if you're rolling a ball down, it'll go down faster on this slope than the slope at m equals to 1. So if you increase the steepness, you're increasing m. So this m will be higher too, and then this one will be 3, m is equal to 3. Okay, you kind of get where I'm going with that. So that's what, there's these two measures or characteristics that make up a line, and that's your slope m and your intercept c. But in this course, we use different notation. You can either find m represented by b or b1, but c, okay, or b1, or c is represented by a or b naught. Right, in your formula sheet, this is what's used. In your calculator, this is what's used, which is why I kind of gave you those two different notations. I'm just going to pause there for a second. I hope I didn't lose any of you, and you're just following me in terms of what I've explained so far. So basically, I've explained like how regression is used in the real world, and on the right, I'm explaining how we use a straight line, or basically what the characteristics of straight line are, which is its slope or gradient, aka gradient, given by this m, and the intercept c. Any questions, anyone? You want me to explain anything better, or spend a bit more time on something that I've just explained so far? Or are you following? I'd really appreciate a thumbs up before I move on. Good. All good. Thanks so much. All right, so let's get back to it. Okay, so you'll get this line that explains the data. All right, so this straight line. Now the thing is, as I just explained, there's so many different lines based on different values of m and different values of c. Okay, so how do we decide which is the best line? So in other words, this blue line that I just drew, someone else could come and say, hey, wait, I think this line is better, this green line. Right? Someone else will come by and say, one more example, wait, I think my line is better, that explains the data, which is this one here. There we go. It's slightly different, especially at the beginning, but it changes towards the end. So there's these competing lines that everyone claims explains the data better. Okay, so there's a way we overcome this by all of us agreeing on which is the best line. And how we do that is, okay, so you won't be tested on this, but I'm just explaining it to you. So just so you understand this. So if you want to switch off now, please do. I'm going to tell you, okay, you need to switch back on, and this is what's going to be coming out in your assessments and stuff. But now what I'm going to do is I'm going to explain how we decide which is the best line, which you won't, excuse me, you won't be tested on, okay? So like I said, let's just consider this blue line, all right? For every point, there's a distance from that point to the line, a vertical distance. So I'm drawing a vertical line from this point to that blue line, this point to that blue line, and let's say this line goes all the way here. You can see the blue line touches this point, so there's no distance. There's absolutely zero distance. But this blue dot, yes, there's a vertical distance from it. Right. Now let's look at the green line. Okay, I'm going to use a different color here, green to keep in with the green line. That first point, okay, you can see it's different. There's the distance. The second point, there's a bit more of a distance compared to the blue line to that point. And here, just give me a second. Oops, my mouse is not moving as I wanted to. All right. Okay, there we go. That's the distance for the green line. Wait, no, sorry, that's my bad. I'm just gonna erase this. You can see that this green line actually touches this blue dot. So there's no distance. But here, there's quite a big distance. So what happens is, let's just look at the blue line. Okay, so the blue line, what you would do is, you look at all the distances for each point away from it. All right, so say this distance here, the first distance is 0. Let's change the color here. Like I said, don't worry, you're not going to be testing on this. I'm just trying to explain to you how we decide which is the best line. So that first point, the distance is 0. The second point, let's say this distance is like 0.5. Okay, so 0.5. The third distance is, say it's 1. And then the last point is 0. Okay, that's the distance from this line. For the green line, okay, the green line, this distance is, say, 0.25, the first distance. The second point here, let's say it's about 0.75. The third point, it's about 0. And the fourth point, it's quite big, so we'll make that 2, etc. Okay, and etc. And you can see this distance is quite big here. So what happens is, what we do is we square each one of them. When I say square, I mean we just raise each one to the power of 2, squared, squared, squared. We do the same for this, squared, and we add it all up. We add them all up, okay? We add them all up. Now this will give us a value. Now the thing is, the line that puts this data the best would have the smallest value for this, because what we're saying is that line is almost overlapping every single point. That means it's touching every single point. If it touches every point, then the distance for each of them will be 0, right? Because every point lies on that line. So the best line would actually be a line that actually has a value 0 here. But the thing is, it's unrealistic to have a line that touches every single point. So the best we can do is we take the line that actually has the smallest value, because that line is closest to every single point that we have, and that would be the best line. So that's how we decide which is the best line. And lucky for us, there are equations. You don't need to memorize the equations, but there's equations that are given to us that actually tell us what the slope, this m value, the c value, or in other words, the b1 and b0, are for that specific line that has the minimum distance. And that is these equations here. This one, I'm just gonna mark it here. That's the equation you use to find the intercept, the c. I'm gonna write c here, and this is the equation, excuse me, we use to find m. That gives us the line that has that smallest distance. I'm gonna pause there. Um, if one of you was switched on and trying to pay attention to that, like I said, you're not going to be tested on it, but if you just understood that, I'm chuffed. I'm satisfied. Does everyone follow that? Or if you won't pay attention, don't stress. But from now on, this is what you're going to be assessed on, and I need you to pay attention now. Let's go back here. Thanks, Victor. Thanks, everyone. All right, so let's move on to some data, which will explain the concept really well. And this is the kind of stuff you are going to be tested on. Okay, so in your assignments and your exam, you're generally going to be given 2 columns of data. So this column and this column. Okay, so I want you to ignore everything else. Every other column after that, ignore. I just want you to focus on these 2 columns, right? So what will happen is you'll be given data in 2 columns in a table format. And what you need to know is what is the independent variable and what is the dependent variable. And those are just fancy terms to say which variable depends on the other. All right. So what I mean by that is, let's look at this data here that's given. Here in the first column, you're given that each of these people, Joel, Sarah, all the way to Ethan, they have months of experience in a certain industry. So Ethan has the most experience, Jill has the least experience. Jill has 52 months experience and Ethan has 77 months of experience. Let's assume that they're all the same job title. Maybe they're all engineers or etc. It doesn't really matter. But now at this point, because they all have the same job, their months of experience would dictate what their annual salary is. And here in the second column, it's showing what their annual salary is in thousands of rands. So Jill earns 381,000 rands per annum, right? Sarah 442, and you can see that the data isn't necessarily ordered in terms of the X variable, or in other words, the experience. Sometimes it won't, okay, but that's not too important. It's just that you understand which would be the X variable and which would be the Y variable, because you're not told that. Now, how you identify that is you look at which variable would affect the other. So think about it this way. Your salary does not dictate how much experience you have. If you had to go for an interview and you tell them this is how much experience you have in terms of months, that would dictate what the salary is, right? So your month's experience controls what your salary is. So this is what your X would be, and this is what your Y would be. Okay, Y doesn't affect X, but X affects Y. And that's how you know which is your X and Y. Does that make sense, everyone? Can you give me a thumbs up if that does make sense? Um, how to identify which is your independent and your dependent variable. Fantastic. Thanks, everyone. Thank you. All right. So the moment you know that, then that's going to help you with your calculator work, because you have to capture this data in your calculator. Now, before we do that, I just want to illustrate the scatter plot that I've done here on the right. And basically, all I'm doing is on your x-axis, or your horizontal axis, I'm capturing months experience because that is what our x is. So I'll put a x here, and then here you have your y. All right, so we know that now. I'm just going to erase this to neaten up because I'll need some space. All right, so I've done a scatter plot. Basically, each blue dot matches up with a row in the table. So Jill has 52 months experience, which is why you see this dot here, and Jill makes 381,000. So that's how you get the y value in the axis. So each one is just one of these individuals in the table, and I've drawn a scatter plot. So we're trying to use a line, and let me just we're trying to use a line to kind of uh, fit this data so we can use to make estimations like this. Okay, now that best line is obtained by solving these equations that you see here. In other words, if I want to know the slope and the intercept of that line, then I need to use these equations. All right, now you can see um, in your formula sheet, these are given to you, so don't stress about it. This sometimes in your formula sheet would be B1, I think, yeah, B1, and this will be B naught. All right, but you can see that the equation for your intercept depends, you can look at here, it depends on B. So that means you have to solve this first. So you have to do this one first before you do the intercept. All right. Now, each value in that equation can be obtained in your calculator. And I'll show you in a second how to do it, right? So hopefully everyone has their calculator and preferably the Casio. So what you're going to do is, now you're dealing with regression, all right? So remember, we were talking about a straight line. As I said earlier, we're trying to solve for the intercept and the slope for this equation, a plus bx, or you could have mx plus c plus mx, same thing, plus bx. All right. So now on your calculator, you will press shift, and then you will press mode. Sorry, my bad. Take it back. Hold on. Press mode in your press on everyone, or AC, whichever. Press mode, then you're going to see the option stat. All right, now you'll choose that same option 2 stat. But what's going to be different from the previous learning units is now that you'll see an option that has this equation here, and in my calculator it's option 2, which is a plus bx. So you're going to select that option, a plus bx. All right, and then you'll see a table with an x column and a y column, and some of you will also see a frequency column, but that doesn't matter. We're not going to even use that frequency for this section. You're going to capture the x values, which is here, which I have in this table, your experience in months, and then your y column, you're going to capture your annual salary, 381, 442, etc. So if you could do that for me now, and then just give me a thumbs up in the chat once you've finished. All right, so capture the x values and the y values that you see in this table. Okay, please give that a shot. And you would see that you would capture about 7 rows of data. I'm going to go see who finished. Go ahead, Victor. I'll come back to it. I'm just going to share the data again. Okay, well, good. I'll just give it 30 seconds more, and then I'll continue. Okay, once you've got the data captured, perfect. The only button you do not press now is you do not press mode. You can press on if you want. You can press the AC, but do not touch the mode button. Otherwise, you'll erase the data. Okay. All right. So after you've captured the data, right? I'm going to show you the long cut and not long cut, the long way and the shortcut to get the intercept and the slope. All right. Here's the shortcut first. Remember, in your calculator, you had this notation, a plus bx. So if you wanted, say you wanted the intercept a, all right, all you need to do is you're going to press shift 1, and then you'll see an option that's reg, and that's regression. You're going to choose my calculator, it's option 5, so you'll choose the option reg, all right, regression, and then you'll see one of the options is a, so you will select that and hit equals to, and that will give you your value for a, which is, you should have minus 115.89. You should have that if you capture the data correctly. All right, and in the exact same way, if you want to get the slope or the gradient, that is the b value, okay, all you need to do is do the same procedure. You're going to press shift 1 regression, and then you're going to select the b symbol. My calculator, it's option 2. If you select that and hit equals to, you get a value of 9.24. Now that's the shortcut, okay? That's the easy way. You would use the shortcut if you can see that the question only gives you uh, a mark for the intercept and the slope. So if they ask you for the line um, of least squares, right? Or in other words, the regression line. They could ask you that, or the line of least squares. It's the same thing. And they're only giving you 3 marks in total. So that means getting the A, getting the B, and then you get a mark for writing out the equation. And I'll explain that in a second. It's y equals A, which is minus 115.89 plus your slope 9.24 and x, right? You would use the shortcut if it is just 3 marks in total, and you can get away with it. But if it's more than that, then you need to do it the long way, and I'll show you how to do that, which is not complicated. There's another thing you just need to note here, okay? And I'll explain that now. You need to say for what is the lower limit and the upper limit of your x values. In other words, this equation that you have here, it only works for the values that you have in your data. That is from 52. If you look at your lowest x value, it's 52. It's Joule's value. So that means the lowest value is 52. So when x is greater than that, and I'm going to write it this way, because this is generally how we write it for limits of x. 52 less than equal to x less than equal to, and the highest value for x is 77. So this equation only holds true for this domain, or in other words, within this uh, limit of x values from 52 to 77. And there's a reason why we say that, okay, is because we can see that this data can be explained by a straight line. It's not a bad guess. However, let's say for values much lower than 52, the data could be different. You could have dots here falling down in an extreme value. So that means the line is really going to badly estimate values that are less than 52. And the same could be for values that are above 77. We don't know how the data behaves after that. So I'll use a different color here just to kind of illustrate something about extreme. The data could be like this. It could increase rapidly. So a line is going to definitely be a bad estimate for it. But we don't know that because we don't know how the data behaves after that, which is why it is very important that we specify the domain of X, which is what I have here. Okay, does everyone understand this? Why we have to specify what the limits of X are? If you don't write the math form, it's perfectly fine. You can write it in words. You can say for X between 52 and 77. That is the same thing. This is just math notation. And it's generally how we write it. But you need to specify this after you write the equation. Does that make sense? Why we have to specify the limits of X before we move on? Before I show you the long way of working out A and B. I'm going to get to that now, but I just need to make sure that you understand the importance of that. Fantastic, fantastic. All right, now that's the short way. The long way is you basically need to show, and look, in practice we don't in the real world we actually don't do it the long way. As you understand, time is money, so whenever we can do it faster, it's always going to be the preferred way. But obviously, as a student, and to show the examiner that you understand how to use these equations, you have to show that you're using the equations and that you know how to pull the values that are used in the equation. And that's pretty simple with your calculator. All right, so we know A and B using the shortcut, but if you had to do it the long way, all right, all you need to do is, all right, your calculator will give you the values that are needed for the equation. So in other words, if you look at the first value n, all right, n, you don't even have to use your calculator. All you need to do is you just count the number of rows of data. But if you're not sure, you can always just go to your calculator, press shift 1, all right, you can press 5, no 5 wouldn't be that, it would be shift 1, give me a second, 4, which is variables, and choose 1 for n, and you'll see n is 7. But like I said, most often your data is so small, you can just count the number of rows and that is your n. So your n is 7. Okay. The next symbol in the equation is the sum xy. Now remember, we have to do b1 first, or in other words, the slope before we do the intercept, because the intercept depends on the slope. So we're going to solve this equation here first, all right, using the long method. So we know n is 7. Now the sum xy, okay, the sum xy, you can get it from your calculator. All you need to do is you press shift 1, like I said, it's sum xy. So you're going to choose the option sum, which is the number 3 in my calculator. So you'll select that, and then you'll see all the summations that you need. You just need to look at which one you want, and in our case, we want sum xy, and you'll see that option in your calculator. If you select it, you should get a value of 243,305, 243,305. All right. So you can get all the values you need from your calculator. You need the sum x, sum y from the same method that I just showed you. If you want the sum x squared, you can do the same thing. Shift 1, option 3 for sum, and you'll see the first option there, which is your sum x squared. All right, and that, if you select that, you should get 32,252. So you can get all the values you need for this equation, and you just show the examiner that you're plugging in the values. So for instance, what you would do is remove all of this. If you pull out all those sum values and you write out the equation, you will get the full marks, right? So in other words, B, or if you want to write B1 equals, doesn't matter, B1 equals to 7, so that's what our n is. Your sum xy, which is 243,305. And if you notice, I've actually done all those totals here in this row for you, okay? But I showed you how to get it with your calculator. I would, yeah, I recommend you get used to using your calculator to find the sum values, okay? Minus, the next value is the sum x, which is 472, okay, times sum y, which is 3550, and then all divided by, so I'm just going to get rid of this, all divided by n. This is now going to do the denominator. I know it's long, but yeah, that's why you get a lot of marks for it, is that you can show you're working. Sum x squared, which is 32,252, minus, now the last part, this part here is not the same as this, okay? This is squaring all the x values first and then adding it. Whereas this part in the end is taking the sum x value. It's taking this value and squaring it. So that's at 472 all squared. Now, my advice to you is don't try to work this out in your calculator, this fractional value, yeah. Okay, it's easy to make a mistake, but you have to show it. So you have to show this working, okay? And once you show this working, then for the next line, instead of trying to put all of this in your calculator, just use the shortcut and retrieve it like how I showed you earlier. Okay, shift 1, find, select regression, look for the b value, the slope, and just press equals to, and you'll get a value of 9.24. Okay, is that clear, everyone? Okay, that's my advice to you. Right, you need to show the working, right, which is what you've done here, but to get the next value, try not to work it out in your calculator. Okay, you can use the shortcut to just show the last step, and you will do the exact same procedure for getting the intercept. Okay, once you've got your b value, you plug it into here, and you've got your sum y value. This value here, you've got it from, I'll check the chat in a second, and then the sum x, which is here. You plug those values in, and you'll get your a value, which should be this. Let me check the chat. So depending on the marks, we decide on the method. Yeah, Karina, but just to be safe, I'd always tell you to just do the long method. You won't get penalized. The thing is, remember, you're just using the shortcut to show the final step. All right, and there's no harm in showing the workings like how I've done here. It's, as I showed you, it's really easy to pull the sum values. Everything that you need from the equation is really easy to get from your calculator. Either way, you're going to use the shortcut just to give the final answer. Does that make sense? But I would encourage you to show your working all the time because it's not long. Perfect. Perfect. All right, just pause there for a second. Is everyone with me? How to get your slope and your intercept and how to write the equation and specify what values of x this equation is valid before we move on. Everyone, so far so good?
Sorry, can I ask something, sir?
Yeah, sure.
After we get that b value, do we also have to specify the limits of x?
Yeah, so you specify the limits of x once you write out the equation. Once you write out the full equation here, like what I've written, then you specify the limits of x. Does it make sense?
Okay. Yes.
Okay, cool. Yeah, so that's when you specify the limits. It's after you write out that full equation. So you're saying this equation is valid for those for these values of x. All right. Now, just to be a bit more technical and more accurate, we generally just write y hat. Okay, there's a reason why we write y hat. Y hat just means the predicted value for y, not the actual value. You won't get penalized for it, but I'm just emphasizing that we write y hat is equal to these values. Okay. Now that you've got this equation, the useful thing about this equation is we can make estimates. So for instance, now that I have this equation, say someone comes along with 70 months of experience. Now if you look at our table, there's nobody that has exactly 70 months, right? There's the person that's closest is, let's say, 73, and Kim actually has 66. So in between these two people, there's no one that came in with exactly 70 months of experience. So now what we're saying is someone comes along with 70 months of experience. So that means our X is 70. And what we want to do is, what is the estimated annual salary this person would have? And all you need to do to work that out is you plug the 70 into this equation, which I want you to do now as a quick exercise. I want you to feed the 70 into this equation and work out what the value is. So that'll be your y hat. That'll be the estimated value. Can you just do that for me and paste it in the chat what you get? So what we're doing is we're estimating the annual salary for someone with 70 months of experience. Someone's got a value. 530.91. Yeah. Anyone else get that? Is everyone okay with that? Before I move on, I'm not gonna just assume everyone's got the same thing. If you're struggling with that, just give me a heads up. But I want you to use this equation: minus 115.89 plus 9.24 times 70. So the value you should get is 530.91. Everyone good? Someone else is telling me you're okay with that, so I'm happy with that. But anyone stuck? Silence. Anyone want me to explain that again? Please feel free to share your thoughts. This is a safe place, and this is actually the place where you ask your questions. To make the most of this collab. If you're not understanding this, if you're stuck, please let me know. Anyone else get that same value, 530.91? Anyone didn't get it? Nobody. Okay. All right, I'm just gonna continue, but please just drop a message in the chat if you want me to explain that, or if you're stuck. So you got your predicted value of 530.91, but I want you to just remember the units for your y. Your units are in thousands, so you do need to provide an interpretation in terms of words, okay, not just the number. So you need to say a person with 70 months experience is expected to have, now remember it's in thousands, so what you would do is you'd multiply this by 1000 if you look at the units for your annual salary. So you would say someone with 70 months experience is expected to have 530,910 rands annual salary. That's the statement you need to provide. Are we all clear on that? Guys, the silence is like really disturbing. Thanks, Victor. Anyone else? No worries. Thanks, Marty. Okay. Right, so that's the kind of question you can get asked, is to make an estimate. And check this value that I gave you, 70. It is, the result that we get is reliable because 70 is within these limits. You can see 70 lies within these limits. If we had been given a value of 90, someone with 90 months experience, then this would not be a reliable estimate. Whatever value we get is not going to be reliable because 90 is way bigger than 77. And we said that this equation is reliable for values between 52 and 77. All right. Okay, so I hope you understand that. The last part of this section that I'm going to go over is the correlation. And it's this ugly equation that you have here. It's this very busy equation that you have here. But don't be frightened by it. It's something that's quite simple to to solve and explain. All right. I'm going to erase this and I'll get to it now. Okay, so in this example, the data that I've shown you is positively correlated. Now, what do I mean by that? Well, what I'm saying is basically positive correlation is when you increase your x, your y increases. A negative correlation is when your x sorry. Positive correlation is when you increase x, your y would increase. But for negative correlation, what happens is as your x increases, so as it keeps going to the right, your y actually decreases. So the y value actually decreases. So the line slopes this way. This is a negative correlation, right? And the example that you have here that I've shown you before, this is positive correlation because you can see that your y increases as your x increases. Can anyone think of an example in real life where we increase our x variable, right? As we increase the x, the y would decrease. I'll give you one example, right? For instance, if your x was the time you spent running or exercising, and the y was your body fat. So in other words, this is your body fat. Now, as you would expect, the more exercise you do, right, as you increase x, what happens is your body fat will decrease. So that's an example of negatively correlated data. Can anyone think of another example? Feel free to just drop it in the chat. Um, I'd like to actually hear what kind of examples you think of, because this is kind of how you apply it to the real world. Anyone, give it a shot. One example will be perfect. So I'm looking for negatively correlated data. So the example I gave you was the time spent exercising versus your body fat. Okay, but does everyone understand the example I'm giving you for negatively correlated data and what I mean by that? Thanks, everyone. Thank you. All right. So you get positively correlated and you get negatively correlated. And the more the rainfall, the less. Yes. Very good, Marty. Very good. Good example. All right. Glad to see that. All right. So the thing is, without even looking at the line, we can actually determine whether data is positively or negatively correlated. And that is by working out this equation here, this R. You don't need to memorize this equation, it's given to you. This R value, all right? You can work with that R value and it'll tell you whether your data is positively or negatively correlated. Now, the thing is, to work it on your calculator, you already have data stored there. So you can work out the correlation coefficient, or in other words, the R, from your calculator. And to do that, remember we're looking for the symbol R, okay? So if you want to do that, you can press Shift 1 regression, which is RAG, and then you'll see R there. And anyone, can you just pull it from your calculator and write it in the chat? Tell me what value you get. What value do you get for R? You can round it to 2 decimal places. Thanks, Victor. Everyone else get similar value? But you know how to get the R value? You should get a value of 0.95. Yes, thanks, Karina. Good, good. I'm glad to see that. All right, so 0.95. All right, so that is a positive value. If it was negative, you would see the negative in the calculator, but it's positive. So it's 0.95. So immediately we know it's positively correlated. All right, the next thing you need to state is whether it's strong or weak. So you can use this as a guideline, okay? Anything from 0.9 and up is very strong, I'm just going to write B strong. Anything from 0.8, you actually have this in your textbook, all right? Anything from 0.8 to 0.9, okay, up to 0.9, you can say it's strong, all right? And I'll explain what this strength means, okay? Then from 0.7 to 0.8, okay, you can say moderately strong. And strong. That's moderately strong. From 0.6, you look at your textbook. It's very seldom we actually get data. We're not going to likely get data like that in your assignments or tests, but it's generally considered as weak. All right. The closer you get to zero, the zero value, and remember, it can be negative or positive, right? So on either side. But if it's close to zero, then it almost has no correlation. And an example of what I'm trying to tell you, right, is like this. Let me show it to you with the diagram so you kind of get a better idea. If I draw, there's your y value, there's your x value, right? There's your x, and whatever it could be. In this example, we have month's experience versus your annual salary. If the data was like this, so the data points are like this, okay. If I draw a line here, now this line is horizontal. That means there's no change in your y. Your y is not increasing. It's not increasing, neither is it decreasing. Your y is not affected at all by increasing x. So that means x has almost no correlation to y, right? However, in this example, you can see that as you increase x, your y is increasing. So there is a positive correlation, and what makes it strong or weak is basically how well your data is aligned. Your line is uh, overlapping those points. All right, so that's kind of how you gauge what the strength of the data is, right? Positively correlated and negatively correlated and weak correlation. So this is weak. Okay, that means if you're changing your x, it's almost like random. You're better off flipping a coin in a way, trying to predict what your y is, because your x variable has almost no effect in predicting y. Does that make sense? That's what a correlation basically tells you. Everyone, all good? Does that make sense? Fantastic, fantastic. All right, now you've done pretty much all the hard work here. This is probably, I've covered pretty much all the difficult parts in this section. The last thing that you probably could get asked for is the coefficient of coefficient of variation. Give me a second. Your R squared value. I don't know if you're forgetting what the name of the term is. Coefficient. Huh. I actually forgot what the name is. R squared is your. Wait, sorry. I'll get back to you. I can't actually forgot what the name of that term is. Okay, but your R squared value is, just pay attention to this part, right? Your R squared, I'll explain what it actually means, which is actually more important. All right. Coefficient. Yeah. Your R squared is simply as I've written it. You take your R and you square it. So in other words, you take your 0.95 and you square the value. All right. And if you just do that in your calculator and tell me what value you get, so you take your R value, which is 0.95, and you raise it to the power 2, and tell me what value you get. Write in the chat. And I want you to express it as a percent. So in other words, if it's 0.892, write it as 89.2%. Yeah, very good. It's about 90.19%, right? If you want to round to 2 decimal places. But it's fine. 90%, I'm just going to write 90.2%. Okay. Try to make it a habit of 2 decimals, but it's fine what you have. Very good, Karina. All right. Very good. I'm glad everyone got this. Now, what does value mean? This is the interpretation you need to provide, okay? Remember the example I just showed you earlier, okay? The thing is we don't want something that's random. We don't want our y and our x to have a random relationship. That means x almost has no predictive power. That means I can change x as much as I want, but that doesn't affect the y. The y doesn't increase or decrease. Now we don't want that. We want an x value that provides some sort of predictive power for y. And this r squared value is a measure of that. The higher this r squared value is, the stronger a predictor x is. All right. And what that means is basically for this 90.2%, right, it's telling us that 90% of the variation, and in this case, our y is our annual salary. So what we're saying is 90% of the variation in our annual salary can be explained by the experience in months. And that's good. 90% is very good. If it was 20%, then it's a poor predictor. Then we're saying only 20% of the variation of your annual salary can be explained by your experience in months. And we don't want that. This is not what we're aiming for. We want something that's a strong predictor. So this is a strong predictor. So your interpretation would be 90% of the variation of your annual salary can be explained by your experience in months. Does everyone understand that? What could be the 10%? That's actually a good question. Well, it's not a perfect predictor, and you'd have a perfect predictor if the line touched every single point. If your line went through every single point, you would get an r squared of 1. That means your data or your x value explains everything there is that you need to know about your annual salary. That means your experience in months is all you need to explain to the T your annual salary. But you would only get that if your line went through every single data point. Does that make sense? Fantastic. And okay, so that's pretty much what I wanted to cover today. I hope everything makes sense. Are there any questions? I'll leave the floor open for a second, but I need to get the name of that term. What is your R squared? What's the other name for it? R squared. I can't believe I actually forgot it. It's your coefficient of determination. Oh my god. Okay. Okay, I always get confused with that. Coefficient of variation and coefficient of determination. Okay, so your R squared is your coefficient of determination. So if you're asked to work with the coefficient of determination, know that it's the same thing as your R squared value. Sorry about that, everyone. I just went blank there. Okay, so that's it from my side. I hope this section helps. Are there any questions? Is everyone good? I hope this section helped. I will make the recording available by tomorrow. And yeah, please practice some problems on this learning unit. It will be in your next assignment. You're welcome, Marty. All right, everyone. Have a good evening and thanks for joining. All the best.